coastline slides across the screen, long curves of shoreline, dark inlets cutting into the land. It looks familiar enough that your brain fills in the rest before you even think about it. Then the channels appear. They branch and spread across the surface, exactly the way river networks do when seen from high above. One stream becomes two. Two become 10. Entire drainage patterns stretch across the landscape. Farther out, clouds drift overhead. Nothing about the scene feels alien. The images coming back from Cassini-Huygens show lakes, rivers, clouds, weather. The kinds of features most people instinctively associate with one place: Earth. And for a moment, that assumption seems reasonable. Saturn rises into view behind the landscape. Suddenly, the coastline is not on Earth. The river channels are not on Earth. The clouds are not on Earth. Every visual cue that normally helps us understand an environment is still there, but the conclusion attached to those cues fails. The resemblance is real. The assumption hiding behind the resemblance is not. The closer Titan looks to Earth, the more dangerous it becomes to judge it by appearance alone. Then, Huygens reaches the surface. Scattered across the landing site are rounded pebbles, smooth edges, worn surfaces, the kind of shapes that immediately suggest one thing: flowing liquid. For a moment, the simplest explanation seems to survive. Rivers carve channels, liquid tumbles rocks. The landscape starts to feel understandable again. Then the temperature enters the picture. Titan's surface sits around -180 degrees Celsius. Cold enough that liquid water cannot survive on the surface. The comfortable explanation collapses almost instantly. The same material that forms rivers, lakes, and oceans on Earth becomes something entirely different here. It becomes rock. Water ice hardens into the landscape itself. Coastlines still stretch across the horizon. Riverbeds still cut through the terrain. But the ground beneath them is frozen water, behaving more like stone than anything familiar from Earth. The Huygens landing site stops looking like a place shaped by Earth rules. Those rounded pebbles are still there. The channels are still there. The shorelines are still there. But the surface beneath all of it has changed identity. What appears to be geology is built from a material that, on Earth, would be poured from a glass. That shift removes the safest assumption available. The landscapes remain recognizable, yet the logic used to interpret them no longer works. Titan has not become less familiar to look at. It has become far less trustworthy to understand. Cassini's atmospheric observations reveal something unexpected. Clouds gather overhead. Not isolated patches, not a one-time event. Entire weather systems build in the sky and move across the landscape. Then rain falls. Channels cut through the terrain. Liquids move across the surface. Rivers feed larger bodies farther north until they empty into enormous polar seas. The sequence feels familiar because the sequence is familiar. Something rises into the atmosphere. Clouds form. Rain falls. The surface responds. The cycle repeats. And suddenly, the landscape begins making sense again. The lakes are no longer isolated features. The river networks are no longer disconnected clues. The clouds are no longer decoration in the sky. They become parts of the same machine. Cassini observed the pieces of that machine operating together. Clouds in the atmosphere, signs of rainfall, lakes collecting liquid, river channels connecting one region to another. The resemblance to Earth becomes stronger than it was before. Not because the materials are the same, because the behavior is. For the first time since Titan stopped looking like a water world, confidence starts to return. Maybe Titan is, in a strange way, Earth running on different liquids. And for a moment, that explanation feels complete. The picture holds together until someone starts keeping track of the numbers. Methane rises into the atmosphere. Clouds form. Rain falls. Rivers move liquid across the surface. The climate keeps operating exactly as expected. Then, Titan atmospheric chemistry measurements introduce a problem. Sunlight reaches the upper atmosphere. Ultraviolet radiation begins breaking methane molecules apart. Some are transformed into heavier hydrocarbons. Some eventually settle back toward the surface. The loss continues. More methane disappears. Then more. The process does not stop. At first, that seems harmless. Every climate loses material and gains material. The system should balance itself. But when scientists compare how much methane is being destroyed against how much appears to be available, the accounting stops working. The climate continues circulating methane through clouds, rainfall, rivers, and seas. Yet overhead, methane molecules are being removed faster than the visible climate system can naturally replace them. The atmosphere begins to look like a reservoir with an open drain. The climate still exists, but the budget no longer balances. That changes everything. The visible system should explain itself. Instead, the calculations point somewhere else. The methane supply should have disappeared long ago. The numbers leave very little room for error. By the visible accounting, Titan should already be running out. And yet, it is not. The clouds are still forming. The rain is still falling. The rivers are still feeding the seas. What looked like a complete explanation suddenly becomes incomplete. The familiar behavior remains on the surface, but underneath it, something is missing. Titan no longer looks like a self-sustaining Earth built from different chemistry. It looks like an imitation. A world performing the motions of a stable climate while depending on something hidden from view. The weather is still running. The question now is why it has not run out of fuel. The coastline returns. Nothing about the landscape has changed. What has changed is what those features mean. Beneath the rivers, the Titan methane cycle keeps moving. Methane rises into the atmosphere, clouds form, rain falls, liquid crosses the surface. The climate continues operating even while methane is continuously being destroyed overhead. The visible world and the atmospheric inventory refuse to match. Something else is feeding the system. Not something visible in the rivers. Not something visible in the clouds. Something hidden beneath the landscape those features create. The evidence points in one direction. The methane cycle survives despite ongoing loss. That only makes sense if an active source continues replenishing the atmosphere. Suddenly, the rivers, lakes, and clouds stop being the explanation. They become clues. The familiar scenery is no longer evidence that Titan is Earth-like. It is evidence that a different planetary engine is running underneath an Earth-like appearance. The landscape remains, but the Earth analogy has been replaced. What looks familiar on the surface emerges from entirely different chemistry below it. That may be the most important lesson Titan offers. A stable climate does not have to be built from Earth's materials. A world can arrive at landscapes that look remarkably familiar while operating through completely different processes. Titan is not a strange version of Earth. It is a different planetary system wearing an Earth-like mask. And the resemblance, which seemed to explain everything at first, ultimately explains almost nothing at all.